Hello everyone, today in this video we'll be discussing the fifth module of OS super important questions. In this video we'll be having 5 questions which will be discussed, and these are the most repeated ones from the previous year papers and the previous schemes. So make sure you watch this video till the end and don't miss any of these questions. Very important questions are there. And before starting, please do like and subscribe. It helps me make more videos like this. And now without wasting more time, let's get started. The first question is, what is a file? Okay, so we have to first understand what is a file. Okay, after which we'll be discussing its attributes as well. Okay, so what is a file? A file is a named collection of related information that is recorded on a secondary storage. Okay, very simple. What is a file? It is nothing but it is having some information inside that, and it is stored in secondary storage. Okay, that is called as a file. Okay, a file can be text, source, object, or executable file. How many types are there? 4 types are there: text, source, object, or executable. And this second question, which is about the attributes of the file, there are 6 attributes of the file. Okay, 6 or 7 attributes. So the first one is name. Obviously we'll start it from here. Name is the only information that is kept in the human readable form. Other all gets converted into binary or machine level language. Okay, so first attribute is the name. Second is the identifier. What is identifier? It is a unique tag. Okay, you just have to remember it is a unique tag that identifies that file. Third is the type. What type of the file it is? Okay, the information is needed for the system that supports different type of files. Like it can be of the type video, it can be type of the PDF, it can be of the type image, it can be of the type audio, and so on. Location, where it is stored. Okay, that is the location of the file. Size of the file, what is the size, how much content is there inside that. And protection means who can access. Okay, who can read the file, who can write on the file, who can execute the file, and so on. Last is the time, date, and user identification. This information might be kept for creation, last modification, and the use. Okay, so this thing why we require is to understand what time the file was at last edited. Okay, so these are the 7 attributes of the files. Very important question. Moving on to the second question, explain in detail about various file operations. Now we have to discuss what is file operation. This is also very much repeated question. So let's understand what are the operations of the file. First is creating a file. Understand it in a natural sequence. First we create something, right? It's creating a file. Space needs to be present in the memory for the file, and a new entry has to be made for the file. Okay, if enough space is there, we will be able to create a file. After creating a file, we have to write some content into that. Okay, to write a file, a system call is made. What is made? A system call is made. Okay, what does a system call do? It specifies both the name and info to be written. In which file what info is to be written, that will be specified, and the file will be written. Third is reading the file. To read a file, a system call is made that specifies the name of the file. Okay, what it specifies? The name of the file where the content is to be read. After the name is specified, from the starting of the file there will be a pointer which will be kept at the place where the content is to be read. Very simple, reading the file. Then repositioning within a file. The directory is searched for the appropriate entry, and the current file position is repositioned to a given value. If suppose that the file is starting from here and I want to read it from here, that is called repositioning within the file. Okay, the fifth one is deleting a file. To delete a file, search the directory for the named file. Having found it, release all the file space which has been allocated. Okay, so this is the directory, and this file I want to delete. Just locate this file and release all the space which it has allocated into the in the secondary memory, so that this same space can be used for some other storage. Okay, last one is truncating a file. What is the difference between deleting and truncating? Both means deletion, just that in truncating we will be not deleting the attributes of the file. Okay, the user may want to delete the content of the file but keep the attributes. Okay, attributes means the name of the file, the when it was created, and who can read, write, access to it, all those things. Okay, those things are called as attributes. So attributes will not be deleted, only the file's content will be deleted, so it will be an empty file. Okay, that is what is called truncation. Next, okay, in this case truncation of the file is used. Okay, these are the these are the operations of the files. Okay, moving on to the third super important question, explain the contiguous, linked, and index allocation methods. Okay, there are 3 methods in which we can use for allocating something. Okay, what do you mean by allocation? Allocation means if there is a request for some data to be stored, we'll have to have some space where the data can be stored. This is called as allocation. Okay, this is called as allocation. There are 3 methods in which we can do the allocation. Let's understand each one by one. Allocation methods address the problem of allocating space. to the file so that disk space is utilized effectively. Okay, and files can be accessed quickly. Both storing the file and accessing the file is possible by using the allocation methods. Let's understand the first one, which is the contiguous allocation. In contiguous allocation, we'll have to store all the files continuously, means one after the other. Okay, this is called as continuous allocation. It requires that each file occupy a set of contiguous blocks. Contiguous means continuous blocks. Okay, one after the other. How to access a file in contiguous way? Accessing a file is easy. Only we need the starting location where the contiguous blocks address are starting from. If it's starting from here, the second information we need is how many blocks are there. In this case, 4 blocks are there. Okay, and the length means number of blocks. If we have the starting address and we have the number of blocks, we can access any of the block by our wish, right? If you want to access the third block, we'll start from here, go to the third block, like that. Okay, so accessing a file that has been allocated is easy. Okay, why? Because we can access the ith block by using the b plus I. What is b? B is the base address and I is the ith block. If you want to have the third block, we can access from the starting point and move to the 3 locations. Okay, so here is an example. As you can see, there are how many files are stored? First is count, second is tr, third is mail, fourth is list, and fifth is f. The starting address is given and the length is also given here. So this count this points to this. Okay, means count is present here. It's starting from 0 and 2 blocks are there. The second one is tr. Tr is starting from 14 and 3 length is there. So this is tr starting from 14 and 3 length is there. Mail is starting from 19 and 6 blocks are there. Mail is starting from 19 and 6 blocks are there. 1 2 3 4 5 6. Okay, so this is how we'll be storing in the contiguous allocation. There is one disadvantage in that it includes finding a space of contiguous blocks. This method suffers from external fragmentation. Here what happens, if you want to store, suppose length 6. Okay, we want 6 blocks continuously. Even if 5 blocks are there continuously and the sixth block is already blocked, we cannot use that space. The five blocks cannot be used because the sixth block is not contiguous. We want to have 6 blocks continuously, then only we can be able to use this one. Okay, this is one of the disadvantages, because always we don't get that. And because of that, external fragmentation will happen, wherein in between some spaces will be left without any use. Okay, moving on to the second method, which is linked allocation. Okay, linked means, oh, you know, right, what is the link? Link means this is linked with this is linked with this, and so on. It is linked with each other. Okay, so it solves the problem of contiguous allocation. If it is linked, means we need not have all the places in the same, all the blocks in the same place. We can use the linking to link different blocks in different parts, and it looks like it's contiguous, right? So that solves the problems of contiguous allocation. Each file is linked list of the disk blocks. Okay, blocks may be scattered anywhere on the disk, so it can be scattered anywhere on the disk and there will be linked attached to it. Reading from a file requires the following pointers. Okay, following the pointers means, suppose that I have 3 blocks with me, 4 blocks are there, and if I want to reach this block, I have to start from here, follow to this pointer, then to this, then to this. Okay, so following the pointers is required. Unlike the previous one, in the previous one we can directly go. If I am present here, if I want to go to the 4th block, I can directly access to the 4th block. But here we don't know which block it is, so we have to access each block and move to the last block which is needed. So here direct access is not possible. We have to go through following each pointer. So what are the advantages here? There cannot be external fragmentation. Why? Because every space will be used, and since they are linking with each other, it is not necessary that they should be contiguous. Okay, they can be at different spaces also, and all the empty spaces will be utilized. Any free block on the free list can be used to satisfy the request. All the free blocks are available for satisfying the request. A file can continue to grow as well as long as the free blocks are available. So there is no space size restriction. The size should be this much only. It is not restricted. We can have as many big file as we need by attaching the free blocks till the end. Okay, means end to end we can keep on attaching the free blocks and the file size will increase. Okay, so it seems like there are no disadvantages to this method, but there are some disadvantages. Okay, direct access is not possible, as I told you. In the previous one we used to access directly, right? If we know the b I block, we can directly access by b plus I, but in this one we cannot access directly. Space required for pointers should be in clusters rather than blocks. So a cluster is more space efficient. So currently it is in blocks. That is one disadvantage. Reliability: the files are linked together by pointers scattered all over the disk. If any one pointer is lost, the remaining links are also lost. What does this mean is, suppose that this is a representation. Here we have a file which is called as jeep. Starting is 9 and ending is 25. We'll start from 9 here, and this is pointing to 16. 16 is pointing to 1, 1 is pointing to 2, and this is pointing to 25. So in this case, suppose that I have lost this one. When I lost this one, I will be not getting the access to this one, access to this one, access to this one. So my only access will be remaining this one. Why? Because I lost one of them in between. This is the disadvantage in this one, linked allocation. Okay. Moving on to the third type of allocation, which is indexed allocation. Okay, so what happens here is it brings all the pointers. Okay, whatever the pointers are there in the whole system, it brings all together into one location called as index block. So this block is called as index block. Okay, index block. This is what is called index allocation. All the pointers are present in one location. Ith entry in the index points to the ith entry in the ith block of the file. Okay, so we can have easily accessed a pointer and the file, pointer and the file. It will all be present in one space. Okay, that is index allocation. It supports direct access without suffering from external fragmentation. One advantage, because any block on the disk can satisfy the request for the more space. Okay, so we can have spaces, means blocks in different locations, but all will be having the pointers in one place. So we'll be having separate pointers for each of these blocks. Okay, and this block will be called as index block. So in this case, we'll not have any problem of external fragmentation. All the blocks will be used, and we can take up any block and satisfy the request for more space. Disadvantage is that it includes wasted space. Okay, in between the space also gets wasted, which sometimes might not be used. Also, the other disadvantage is many pointers are required here. Okay, so this is an example here. The file name is zip and the index block is 19. So 19 is pointing to 16. This is one pointer, this is one pointer, this is one pointer, this is one pointer, and so on. Okay, so all the pointers which are present inside the file zip is present in one location called as index block. Okay, now if the index block is too small, okay, if this block is very small, it cannot hold enough pointers for large file. Large file will have many pointers. Okay, more than 100, 200 pointers will be there. So it cannot control, means contain that. So there are three mechanisms to overcome this. To ensure that all the large files are contained in this, we have three mechanisms. First one is linked scheme. In linked scheme, what happens, index block can be linked with 100 other blocks in one group, and so on. So each of these will again be further linked. This will be linked to 100 block, this will be linked to another 100 block, and so on. Like that, if you do, all the blocks still will be in the same place with more levels. Okay, that is linking. And second is multi-level index can also be used, where the same thing happens in a hierarchical fashion. Here also the same thing happens. Each of these block will be having further more blocks, but the implementation will be different. Okay, that is the second one. And third one is combined scheme. In combined scheme, what happens, the combination of direct and indirect blocks. Direct block means if 9 is there and I just want to store 9 as like that only, and do not want to use it as another index block, that is direct one. Indirect means 9 is also pointing to some other ones, that is indirect block. So in combination scheme, both direct and indirect blocks will be there. Okay, that is a combined scheme. By using this, we can almost fit all of the pointers of the large file inside this index block. Okay, so that was about the allocation methods. And moving on to the fourth super important question, access matrix. Okay, explain access matrix method of system protection with domain as objects and its implementation. Two questions are asked. First, you have to explain the access matrix with the domain as objects, and second is what are the implementations of access matrix. So what is an access matrix? What is matrix? Matrix is a 2D array with rows and columns. This is called as a matrix. And access matrix is what? The matrix will have the information about the access. Who can access what? Okay, that is what is called as access matrix, whose rows are domains and columns are objects. Okay, so each entry ij denotes what access is given to the object j in domain I. So well, if I show you the figure, you will be able to easily understand this. So here see, these are the objects, file 1, file 2, file 3, and printer. And these are the domains in which directory it is, directory 1, directory 2, directory 3, directory 4. These directories are present here, and these are the files present here. Okay, or the objects present here. Now in the directory 1, file 1, read operation is given. So the users who want to access the directory 1 and file 1, they can only read the content. If they want to read and write, they have to go to the directory 4. Okay, and in directory 3, the file 2 can be read and file 3 can be executed. D2 can be printed. So like that. Okay, so in which domain, what is the scope, and what files or the objects can do what operation, that is specified in the access matrix. Okay, So what are the implementations of the access matrix? There are different methods of implementing access matrix. First is global table, second is access list, third is capability list, and the fourth is lock key mechanism. Repeat with me. First is global table, access and capability list, lock key mechanism. Let's understand the first one, which is global table. In global table, what happens? It is the simplest implementation of access matrix. Okay, a set of order triplet domain object and write set is maintained in a file. So imagine there is a file here. Okay, in that file, what is there? In which domain what objects can do what? That triplet is stored. Okay, and second line will store the second kind of information, third information, fourth information of this triplet. Okay, in what domain what objects can do what. Okay, what is the drawback? Table is usually large and cannot be kept in the memory. Okay, next is access list for objects. What do you mean by access list? Okay, so if I tell you what all you can access if you go into the mall. Okay, if you go into a shopping mall, what all you can access? You can access the objects present there and have a look into it, and you can use that object to uh, decide whether you want to purchase that or not. You can access the waiters or the salesperson who are present there. You can access them for information. You can ask them what is the information about the product and the price and so on. So your access domain will be including the product and the salespersons. Okay, so the list which contains all those accesses is called as access list. Okay, so each column in the access matrix can be implemented as an access list for one object. So one object in which domains it can do what. Okay, so access list for f1 will be d1 read and d4 read write. So f1 can do read in d1 and read and write in d4. Okay, like that. That is called as access lists. Okay, the resulting domain list for each object consists of ordered pairs in which domain they can do what. Okay, capability list for domains. A capability list for a domain is a list of objects together with the operations allowed on those objects. So it is a list of objects. Okay, object 1, object 2, object 3, object 4 in one particular domain. What objects can do what. Okay, so to execute an operation M on object OJ, the process executes the operation M and specifying the capability for the object J as the parameter. Simple position of capability means that the access is allowed. Means if you want to perform an operation M on object J, whether it is allowed or not, that will be present in the list. Whether it is having the capability of executing the process M, object OJ, can it execute the process M or not? That will be decided by the capability list. Okay, last one is the lock key mechanism. Okay, lock is there and key is there. Okay, the lock key scheme is a compromise between access list and capability list. Each object has a unique list of bit patterns called as locks. So who has locks? Object has locks. Repeat, object has locks. Okay, and each domain has a unique list of patterns called as keys. So the object will be having a lock and domain will be having a key. Now key can open a lock, right? So a process executing in a domain can access an object only if the domain has a key that matches the lock of the object. Suppose that there is a process P running. In that process P, it is running inside the domain D, and it wants an object O. Now, if that object O has the lock which D can open, then only that domain can access that object for that particular process. Okay, so this is what a lock key mechanism is. These are the four implementation of access matrix. Moving on to the last super important question from the OS. Given the following sequences, okay, this is a sequence given with the track 50, starting position is 50 and the ending track is 199. What is the total disk traveled by the disk using FCFS, SSTF, CLOOK and CLOOK algorithm? Okay, apart from this there is scan and C-scan also, but the most repeated ones are these four. Okay, so let's understand this question. First you have to write FCFS. Okay, FCFS means first come first serve. Now what we are actually doing is the starting position will be writing 50. It's given in the question the track 50 is the starting position. So we have written here 50. After you have written 50, what's the next thing you have to do? You have to go to all of these. Okay, you have to go to all of these and calculate how much you are going. Means you start from 50. Next one is first come first serve. Since this is FCFS, the first come will be first served. Okay, so 95 will be taken into consideration. So 50 to 95, how much distance traveled? 45. Next 95 to 180, what is the distance traveled? 85. Next 180 to 34, the distance traveled is 146. See, 180 is here, 34 is here. It will come back. That distance also will take positive only. So whatever the distances are present in this order, that will be taking, and finally we'll be calculating the total distance. That is called as FCFS, first come first serve. Okay, first method. Second is SSTF, which is shortest seek time first. Here what happens is we are starting from 50, and which number is closest to 50? Okay, which number among these is closest to 50? Tell me, which number is closest to 50? The number closest to 50 is 62, right? 50 to 62, it is just 12. Rest all is more than 12, right? So we'll be taking first as 62. After we have taken 62, which number is closest to 62? That will be taking. Closest to 62 is 64, so we'll be taking 64 here. Okay, after that the number closest to 64 is 34 here, right? 34 is the closest one. Okay, we have taken here the number closest to okay, 64 is present here. The number closest is 34. After 34, the number closest is 11. Okay, see here 11. If you calculate the differences between 34 and all the other numbers which are not used, the least difference will come as 11. So after 11, which is the closest? After 11, the closest is 95 among 95, 109, 123, and 180. The closest one is 95. So we'll take 95. After 95, it is 119. After 119, it's 123. After 123, it is 180. So we'll calculate all the distances between them and calculate the total distance. Okay, that is how you calculate using SSTF. Third one is look. Okay, what is look? Okay, see, this is very easy to understand. Here what happens, 50 is here. Okay, we are starting from 50 and we'll be moving in one direction. Okay, see, the numbers are like this. Okay, 0, 1, 2 till 199. Okay, like this it is there. We are at 50. Now we can move either this direction or this direction, that is upon us. Okay, any direction we can move. So I'm choosing to move in the right direction where 62 comes. So if I move in the right direction from 50, I'll be reaching 62 first, then I'll be reaching 64, then I'll be reaching 95, then I'll be reaching 119, then I'll be reaching 123, and then I'll be reaching 180, right? If I keep on moving into the right direction, I'll reach 180. After 180, there is no more number which is greater than 180 in the right direction. 180 to 199, is there any number which is given in the question? 180 to 199, any number is given after 180? See, there is no number given after 180. So I'll come back means I am at 180. I'll come back and see which is the first number I encounter. First number I'll encounter is the 34. Okay, because all the other numbers are used, only 34 and 11 is remaining. So when I come back from 180, I'll be encountering 34, then I'll encounter 11. I'll calculate all these distances, I'll add up. That answer is the answer for look by using the look algorithm. Okay, so this is how you do. You can also go in the reverse way. First you can go to the left. If you go to the left from 50, first you will encounter 34, then you will encounter 11. After that you will go to the right and you will encounter 62, and the same loop will come till here. You will stop at 180. Okay, that can also be done. Both are valid. So that was about the using look and using C look. C look means it takes a circular turn without changing its direction. So here what it means, again the same thing, you can start from 50 and you can move to the right, or you can move to the left. I'll choose to move to the right. Here I'll go to the 62, then I'll encounter 64, then 95, then 119, then 123, then 180. Now I am at 180 here, but I cannot change the direction. Okay, I cannot change the direction means here 0, 199 is there. I am at 180. I cannot change the direction means I have to move to the same direction, and after I reach 199, I'll again start from 0. Okay, like that it is. It's like a circular. If I go here, I'll be coming back from here. Okay, like that. So from 180, I'll be going to 119, and 119 will be turning to 0 because it's circular. And then from 0, I'll be continuing my journey. So from 0, when I continue my journey, I'll be encountering 34 first. So I'll be taking 34 here. Sorry, I'll not get 34. I'll get 11 here, right? So yeah, I made a mistake here. So first I'll be encountering 11, and then I'll be encountering 34. Let me correct this mistake. I think the answer might be same, but still let's not keep the things as wrong answer. Okay, see, first we'll be encountering 11 here. Okay, then we'll be encountering 34. Okay, now if it is 11 here, this answer will be 11 here, and this will be 34. Okay, this will be 11 and this will be 34. 34 plus 11, 34, 44, 54. Okay, 54, and 54 plus this answers. Okay, so the answer which I'll be actually getting is 194. Okay, 194. Got my point. Okay, so this is the answer which you'll be getting using CLOOK algorithm. Okay, so these were the super important questions from the module 5. And if you like this video, please do like and subscribe to my channel. It helps me make more videos like this. And thank you so much for watching. I'll see you in the next one.